Hi all, welcome to Soumya's Tech Talks. Today in C Programming Lecture 8, we will continue with bitwise operators. So here today we will discuss on bitwise OR and left shift, right shift, and we also discuss small program how to set a bit at particular position in a 32-bit integer. So let's continue. So today we will discuss on bitwise OR operation. So it is performed on two binary operands, means both operands are single bits. Okay. So it's usually the behavior is if both operands, for example, if both are having multiple bits, like if you are doing bitwise OR for integers or sort, which contains multiple bits, the OR operation will be performed on corresponding bits in each operand. So we will discuss it with an example so that you can understand. And the behavior of the OR operation is if any one of the bit, like if you have two binary operands, if any one is in any one of the operand is 1, the result will be always 1, otherwise zeros. So you can see the truth table. It is called a truth table of bitwise OR. If you see only in case of both operands are 0, then it will give the 0 result. So any one of this operand is 1, then the result is 1. This is the truth table of the OR. So you have to remember this. Okay. So we will see with the example. Here I took a two decimal numbers. One is decimal 179. So here the below is the binary format of the decimal, and I took another decimal 72. Its binary is this one, and now I will do bitwise OR for these two. So let's see graphically animated way how it happens. So first it will start with two uh, MSBs, and it will do the OR, and that result will be stored in the MSB. Here both are 0 and 1. Here 1 it is 0, so the result is 1. It is stored in the corresponding place. Like this it will continue. You can see the animation. It will continue for each corresponding bits, and the result will be stored at corresponding location only. So here I took 8 bit, but you can take any larger binary number. It's 16 bit, 32 bit, whatever it is, it will be done in same way. So now once all operation for all the bits are happened corresponding bits, the result is like this, and the actual result is when you convert into decimal, it is 251. So now we will go to the left shift. Left shift means all bits will be shift left side. So you can shift one time or n number of times, any times you can shift. So for each shift operation, the leftmost will be, because you are shifting to left, the leftmost bit will be lost. Okay. So in the right side, it will, there is, when you shift the right side, there will be empty bit, means the right side it is shifted. So there will be empty space in the left right side. So it will be padded with 0, 0 means 0 will be placed, and the syntax for this is it is like this. So you have a operand 1 and operand 2 in between. This is the symbol in C language, or in many programming language this is the symbol for the left shift. So what operand 1 is on which you are doing the shift operation. Operand 2 tells how many times you want to shift. Okay, we will see with a one example also. Let's say I will take this decimal 251. So this decimal 251 and this corresponding binary is this one. Now I will do a shift operation on this one time. So if I do shift operation, you can see one time it shifted. So here it will be lost. The left side, whatever shifted, it will be lost, and right side you have a empty space will be created. So now what it happens? So this is lost, the leftmost is lost, and the right side there is an empty space. Okay, there will be a padding added. So this is lost, and here some padding is added. So that's how the shift is performed. Similarly, right shift also it is same as left shift. So all bits will be shifted to right side. Either it can be one time or n number of times you can shift. Okay. each shift operation rightmost will be lost, and for each shift operation left side there is a empty space, empty will be created and it is padded with 0, and the syntax is like this, same as left shift. So now I will do a right shift with the example. So I took same 251. Now if I do the right shift, you can see, so I did a right shift, so the rightmost will be lost and the left side there is a empty. Okay, you can see this. So now a padding will be added, means wherever the empty space in the left side will be padded with a 0. So this is how the right shift left shift happen, and we also discuss OR operation. Now I will show you simple program like how to set a bit. Let's say you have a integer or a sort. So integer is a usually 32 bit and sort is 16 bit. When I ask you to, out of this 32 bit, I will ask you at any position, like at position 4 or position 5. Out of these 32 bit positions, I want you to set at wherever I ask, I will tell you a position, and there you have to make that position as 1. If it is 0, you will make it 1. If it is 1, you will left it as 1 only, like this. But you should not disturb at other positions. Only that particular position you have to set 1. So rest you should not disturb remaining bits. So we will see with one example. Okay, let's say I will take this decimal. So it is a 15204. This is the binary representation of this, and I want to set at fourth position. Fourth position means 1, 2, 3, 4. Here it is 0. So I want to make this 0, this bit to 1. So how to do this? We will explain. So first the procedure is, so first I will take to do this, I will take 1 decimal 1, which is the binary is like this. So always you have to take a decimal 1, and after that what you will do, this decimal 1 you will shift. Let's say you want to set a fourth position, so you have to 4 minus 1 3, means 3 times you have to do shift to left side. So if you want to set fourth position, it is 3. If you want to set eighth position, 8 minus 1, 7. So you have to shift left side 7 times. Like that, what is the position you want to set minus 1, you have to do that many times. This decimal 1, you have to shift to the left. So I will do this. So if you do 3 times, if you see, here it is 1 and here it is a padding and this will be lost. So if you see, wherever you want to set a fourth position, there you got 1 and remaining all zeros. So after that what I will do, I will perform OR operation on this. Okay, so here see, so this is your actual decimal which you are doing, you want to set. Okay, here I took 1 and shifted 3 times. So which position you want to set, there I am having 1. If I do R, so remaining position won't change because it is 0 and here 0, 0 and R 0. It is 1, here it is 0. So if you do R, it is 1 again. So it won't change. This position won't change. If you see any position, it won't change. But the fourth position, it is 0. And if you make it R, it becomes 1. So only this position will change. If you can see this, all are same, only the highlighted position, this is our interested position which I ask you to set 1, that is only set to 1, rest is not disturbed. So to set a bit at a particular position, you have to use left shift and R. So this is the algorithm for the setting a bit at particular position. Now let's see the sample program. So here you can see I took integer a and I took assigned it with this integer. It is in hexadecimal format. We already discussed about hexadecimal format in the previous lecture. And this hexadecimal, the equivalent decimal value is this one. Okay, and I took as the algorithm we discussed, I took another variable b which is assigned to 1. So I want to shift 4 times, so I took another variable num shifts assigned to 4, and I printed this value before shifting. And then what I did, as per algorithm, I have shift the 1 to number of shifts minus 1, means 4 minus 1, it is 3 times. I am shifting to left side, and then I did OR operation on A equals to A OR operation, this is the symbol, and then this B. So now I have set the bit. Okay, so you can, I will print it, I am printing the value after this the setting the bit. So you can run and see the result. Yeah, you can see the result. I put the breakpoint. So see, you can go one by one. Before this is the number before setting a bit, and once I did, so this is the result after you set. Okay, so this is how you can if anyone asks you to how to set a bit at particular position, you can use this algorithm and this program. Using this you can do that. Okay, today we will end here, and we will continue next lectures with the remaining bitwise operators. And thanks for watching. Keep learning, and also don't forget to share this video to your friends and colleagues who are interested in learning advanced concepts in C programming. Thanks to all. Bye.